In math, we use different sets of numbers. And what I mean with different sets of numbers is, well, a set is like a group. Some numbers belong to a different set or a different group. For instance, natural numbers. This set of numbers is your counting numbers. You start at 1, and then you go to 2, 3, as if you're counting, and it keeps going. Whole numbers includes all of the natural numbers, but then it adds 0 to the set. So you start at 0, and then you proceed to 1, 2, 3, and so on. Integers. This set of numbers includes all of the natural numbers. It includes all of the whole numbers, but then it adds negative numbers. So you have 0, 1, 2, 3, and so on. But then it also adds negative numbers. So you have -1, -2, -3, and so on. And then we have rational numbers. Rational number is any number that can be described as a fraction. For instance, if we have a number, let's say a over b, if a number can be described in this way, the only rule here is that b cannot equal 0, simply because you can't divide any number by 0, so that would make it undefined. But any number that can be represented as a fraction, a over b, where b cannot equal 0, is considered a rational number. What does this mean? Well, it means instead of just your whole numbers or your integers, you also have numbers in between. Easiest way to show this would be on a number line. So if you have a number line here, then you have 0, and you have 1, and you have 2, 3, 4, and then you have your negatives, -1, 2, 3, 4, and so on. This number line keeps on going. So -1, -2, -3, and -4. Okay, so the ones that are labeled here, the numbers that are labeled, are actually your integers, but then your rational numbers are numbers that would appear in between all the other ones. And so there's like an infinite number of rational numbers in between each of these integers. So for instance, 1/2 would be about there. If this is 1 here, you have 1/2 there. Here, let me change the color for some of this. So 1/2 could be a rational number. Also, 3/2. 3/2. So it's in the form a over b, where a in this case would be 3 and b would be 2. It also could be negative rational numbers. So a number over here, -2.5. -2.5. And it doesn't always have to be a half. So it could be a third, a fourth, a fifth, or 2/3, or any form of fraction. Now, you may be saying, well, this number isn't actually written in a over b, but it can be. We can convert it so that it is in a over b, because -2/2 is the same thing as 5/2, a -5/2. Okay, that's the same thing. And now this is in that form a over b. Now, if you can't see how to convert that, then look at a lesson on on converting fractions, specifically converting mixed numbers into improper fractions, because that's what we do here. The negative 2.5 would be a mixed number, and I'm not going to go over that here. I just want to show that rational numbers could be any number on the number line, not just the natural numbers, whole numbers, or integers, but any number in between. This should kind of make sense to you. I have seen some places where you'll see a graphic. It's called a Venn diagram, where you have the natural numbers, and I'll just put an N for natural numbers here, and then they'll add a 0, and that'll include the whole numbers. So you have whole numbers, and then integers, you add negatives, so like -2, -1, -5 would be included in the integers. Okay, so you see how integers includes the natural numbers, it includes the whole numbers, but then it adds the negative numbers. That'd be integers. And then the rational numbers would include everything else, all the fractions. So 1/2, 1/3, 2/3, -5/7, any of the fractions. And the fractions can also be decimals. So if you see a decimal, that's also a rational number, because those can be represented as a fraction. So for instance, 0.3 or 3/10 can be represented as 3/10. So any decimal you see, like 0.3, would also be included in rational numbers. Okay, I hope this makes sense for you.